I'm going to be talking about distributed workers, which is a proposal to extend the web client programming model to support distributed computing. And this is work we've been discussing in the context of the Web and Networks IG inside W3C. So the problem statement is that all browser hosts are limited, and they're more limited on portable devices. But generally speaking, performance is always going to be insufficient for some applications. And on portable devices, you're further constrained by batteries. So web apps are limited by the browser host. There's often more computation available elsewhere on the network. And a lot of web apps use the cloud, but the cloud has long latencies, relatively speaking, and also has location and privacy and confidentiality constraints. So if you're in a business, for example, you may want to offload to your own private cloud and not to the main cloud. And just to get an idea of the latency impact, going to the cloud, can be on the order of, 50 to 100 milliseconds, whereas for interactive rates, you want something like 10 milliseconds. And you also need time for compute. So the communication time is a serial overhead, which can impact the performance of high performance applications. And a good example is to be a game where you want to get around 50 hertz at least. And it's hard to do that when your communication alone takes 50 hertz. Now, the issue with accessing distributed resources is limited by the programming model. It's relatively complicated to set up, and this impacts the scope of applications that can use it. So we want to find a way to simplify access to distributed resources. So I'm going to talk about distributed computing resources. So generally, the web programming model is a client-server model. We mostly just think about compute on the server or on the client. But, distributed computing resources is everything else, right? And there's two large categories. There's edge computers, which are sort of cloud-like, but don't live in the centralized cloud. And this can include content distribution networks, ISPs, computers, including the one that you might get in your house, private clouds and businesses, and computers integrated into, say, 5G or 6G services, MEC. But there's also can be other computers you have, say, on your LAN. So maybe a homeowner has a laptop, a phone, and a desktop, and they want to offload work from their phone to their desktop. So in general, though, the kinds of applications we're interested in are ones that are location sensitive. So they are sensitive to latency and privacy. We also need to take into account that these distributed resources are going to be less elastic and less reliable and more diverse than the cloud. And so we have to deal with things like a resource going offline suddenly, or negotiating among different options and picking the best one and so forth. Now, there's different models of edge computing. One very common model is to extend computation on the server and moving computation on the server down into the edge resource. This proposal takes a different approach of extending the client programming model, including the sandboxing of the computation on the client. And we want to find a way to do this that's compatible with existing web programming models. And we also would like to give the client the power to decide when and where to run the code. So the application developer, deploys the code, but the client gets the power of where to run the code and what data to give it. So we want to give the client control over their own data, and also enable the use of the client's own hardware or the hardware of their choice. So in general, the application model we're looking at is to push work up from the bottom and migrate work from the client into the distributed computing resource. So the crux of the proposal is we already have an API in the web programming model that's close to what we need. It's called web workers. And web workers currently let you run compute in another thread. But what if that thread could be on a different computer? It turns out that the communication model with web workers is pretty close to what we need to communicate across the network. And since web workers are well known and understood by web developers, they can immediately begin using them. We just got to figure out the plumbing for how to get workers to run somewhere else. And so that plumbing is we need an environment to run the worker in. That environment needs to preserve the sandboxing properties of the client, and also perhaps provide isolation, and some assurances about safety of that client. We need to be able to find a service to run this. We need to be able to compare multiple options, and we need to manage the execution. And the other thing to say here is that, well, the packaging of the workload needs to support good efficiency. If the purpose is to get more performance, we want to find a way to package workloads that give us that performance. Fortunately, there are things like WASM that give us this performance, and we can also look at other options. The other thing we'll say is the workload gets pulled down from the server. It doesn't get sent from the client. This is to avoid having 2 trips instead of 1. And in general, the edge computer or the target computer will have better connectivity. So the target computer and the compute utility running on it, which is a service, would complement the browser. And discovery and execution are supported by essentially RESTful APIs that the browser can talk to. So we want essentially a discoverable web service for the compute utility. We want to have a way to package a workload for a worker. And we want to extend the worker standard. And we also want to support being able to run these services anywhere. So the discovery mechanism shouldn't be tied to running in Mech or something. It should be something that is extensible. We also need to standardize the interface. So this web service would have to have an API that is standardized. We would not be standardizing the implementation. There's many choices for how to implement this, and we would provide the ability for many different people to provide these kinds of implementations. So for more information, please contact me, Michael McCool. You can also join the Web and Networks Interest Group, and I have 2 URLs there for that, including meetings at TPAC if you're here at TPAC. And then you can also look at this document we've written talking about client edge cloud coordination use cases. And I want to close by saying there's more than one way to satisfy this objective, and the distributed workers is just one option. Thanks very much.